Whoa, are we here? Where are we? Yes, we are. Hoo hoo. Okay, sound testing. Yes. Wait, is this better? No, it's not better. This is better. I think it's better, no? Yes. Okay. Three, two, one. Woohoo! Welcome, Parametric Camp. Choo choo choo. Oh, I wonder if I'm ever going to stop doing this stuff. Okay, where do I have? Where do I have? Wait, wait, where do I have the stuff? Uh, Here. Okay. All right. Good morning, everyone. How's everyone doing? How are my microphones doing? Are they going to abandon me to the course? No, I don't think they are. So, welcome everyone. This is Jose Luis. This is Parametric Camp. We do computational design tutorials, live streams, cool stuff. Not because I do it, but just because I think it's cool in general, even if someone else did it. And then we have social media. If you want to follow us, we announce when we go live on Instagram mostly. I'm very much an Instagram user these days. Are people still using Facebook? Not that I mean Instagram belongs to Facebook, but I have this I have kind of abandoned Facebook. I have to say it's kind of nice. I think. Anyway, what if you are new to the channel? Make sure to consider subscribing, consider turning on notifications, maybe liking the videos that we do. What we do is we typically go live on Fridays and we record some tutorials that we record them live and then we trim them and edit them and turn them into nice videos that people can watch. It's just that this last week I've been doing an intense hackathon of live streaming because there's this series that I'm working on, Introduction to Parametric Modeling, that I really, really want to finish and I really want to wrap up. And we have a lot of content already. I think I uploaded yesterday, I uploaded 29 videos yesterday. So we're going to have a lot of stuff for the summer. And I uploaded 29 videos. Yeah, that was pretty good. Hey, Alasto, good morning. How you doing, sir? And what else? And yes, what we typically do on Fridays, but last week I was doing this, and this week I'm going to continue because I didn't finish. I didn't get as far as I wanted. So we're going to continue that. And, And, oh, what? Wait. I need my computer here, right? I'm gonna need my laptop. Never mind. Well, I'm really distracted today. And also, if you want to stay up to date with what we do during the week, we have a Discord server where we have offline conversations, and we have a few channels where people can post questions. We have conversations. We have a bonfire, etc., etc. Hey, Thomas, long time no see. Good to see you. And then we also have a channel on the server where people can introduce themselves and say hi and who they are and where they're coming from. I like meeting people and understanding why you're here. What do you want to see? And also we have a Google Calendar. If you are a Google Calendar person, you can subscribe to this calendar and you will see when we go live. Nylan, what's up? Hello, sir. So yeah, we have all of that going on. So what we're doing this week is we are continuing with the work that we started last week with the Introduction to Parametric Modeling series. We are pretty advanced. We've already seen a lot of stuff. We've seen nerves geometry, basic geometry. We've seen data tree manipulation. We've done a lot of examples. So I think at this point, What I have left is just, what do I have left? What we have left to do is I need to record a tiny, like a couple of things that I left undone from last week. And once we have that, we can go back to lists. So we've seen data tree structures in Grasshopper. So I would like to take a look at lists and do list manipulation. So for that, we're going to, and I would like to do a lot of exercises, a lot of examples on list manipulation, because it's a very important topic and it's typically a little neglected, and it's definitely super important to understand. Any questions so far? How's everyone doing? Kaushik, oh, you just joined the Discord server, correct? Did you? I see your icon. I've seen it on Discord this morning, I think. You introduced yourself on the channel introductions, but you didn't really use the template, so we don't really know where you're from, what do you like, how do you join the community, etc. So feel free to reintroduce yourself using the template. That would be super helpful. Kaushik, or shall I say the Kaushik? I don't know how to pronounce that. Okie dokie. So let's get back to business, okay? So I'm going to fire Rhino, and we're going to fire some Rhino, and what do I need to do? I need to record. What do I need to do? I need to record an introduction to the exercise that we did. So remember the exercise that we did where we extracted this, circular apertures? I forgot to record an introduction to that exercise. So I need to do that right now. And also I have, I'm kind of with, so I wrote here that we should, let me pull my notes up. So I wrote here that we were going to do that. I forgot to record the introduction, so we're going to do that now. And I wanted to do a brick wall, but I wonder if that's too much for now, or if we should do that when we do the exploding brick wall. We're going to do an exercise that is going to be a brick wall that we're going to explode it with a bomb. It's going to be really cool. It's going to be, we're going to use, that's going to be for randomness. And then the umbracle is going to be a short video pointing out to the other video. And then at that point, I think we're good to start doing lists and list manipulation. I need to plan. I need to plan. I need to plan what is next. So maybe I do like a few videos this morning, and then this afternoon we sit down together and we plan what are we going to do for the rest of the week, because I don't have time. I don't have time to do that offline. I don't have time to take for myself and to plan these things. Maybe I could. Why? What is going on with my connection? Why is my connection flickering? That was weird. Let's start with what we have, and then we can, I also want to record a video. Shoot video for ending of GSD playlist. Okay. And I'm bad with battery, so if battery goes, just let me know. We need to change that. So Okay, so I'm going to, where am I? Here, stream, here. On my stream, I'm going to do here, files. We need to open the file with this roofing. Yep. And oopsies. Huh. Okay. And what we're going to do. Hey, Terence. Good morning. How are you doing? I'm going to do more of these, and then going to be smaller openings, and then this is going to be tiny openings, and I'm going to bake this here as well as a group. Yes, and then I'm going to bring that over here. Huh, that's kind of nice. Okay. And then what do I want to? Okay, and do I want to do render? Yeah, I can do render, but this one. Okay. Okay, and then I'm going to use the Kunsthaus Graz image. Well, I mean, I think if I use this, it might be a little misleading, right? So I'm just going to I'm just going to hide this and hide this, and then I'm going to have the surface here. Maybe I need to show. How am I going to start this? Hide this as well. I'm going to hide this. Yes. And then, oh, that looks terrible. Okay, I think we're going to start with this. All right. So this is going to be the intro video to this, the intro clip to this video. Okay. Okay. All right. Okay. Hi. This is Jose Luis, and welcome to another video in this series, Introduction to Parametric Modeling. In this video, we're going to do a hands-on exercise where we're going to take a surface, all right? And then we're going to imagine that it's some kind of roof for the building, and we're going to make these apertures that are going to go, I'm going to go for a square sort of subdivisions of the surface, and they're going to end up into these circular openings. So we're going to imagine that these are some kind of like oculus kind of lanterns or roof-like elements. And of course, we would like to control how many of these elements are in each direction. And of course, we will also want to control how big the aperture of these windows are, how big, how far away they are from the surface, or how close they are to the surface, and all those things that we like doing with parametric modeling, right? So that at the end of the day, we can explore different variations, different versions, and decide which one do we like better, which one goes to production, which one we send to the competition, whatever that is, okay? So this exercise is going to be super interesting. We're going to learn a little bit of more advanced domain subdivisions of surfaces. We're going to learn some properties of how to loft surfaces, and we're going to do a little bit of data manipulation, not too much, okay? So join me on this hands-on exercise, and as we go through the simple version of this exercise first, and then the more advanced, the one that you're actually looking at on these renderings right now. Let's get hands-on. Let's do this. All right. Let me write in my notes here that I just did that. So that's going to be morning of what day is it today? 24th? What is it today? 25th already? Oh my god. Oculus. All right. What else? What else do we need to do? I want to shoot a video. Let me close this. Let me close this as well. Actually, let me close this. Okay. Oh no, Rhino, where are you going? Okay, so what is the next video that I'm going to do? I'm going to do a short video where I'm going to point folks to the algorithmic modeling challenge that we made for the umbracle. Oh. Alright. Hi. Okay. Should I move away from myself? Wait. Can I look? Okay. So what are we doing now? I'm recording a video where I want to do the umbrac. So maybe I should just open the exercise in. I should just open the exercise. Where do I have those files? Algorithm, umbracle. Yes, here. All right. This is nice. What? Okay. And so that's there. That's working great. And then okay. So we're going to do this one. No, this one. Do I have a better? Is there any better image here than that? No, there isn't. How about this one? This one is nice. Can I use that image? Do I have? Okay, so more tools, usage right, create Creative Commons licenses. Where do I find an image for this? So Thibas, good morning or good afternoon. I'm not sure where you're based. I like this one. This image is quite nice. And okay, so Javier Yayatur. Okay. Okay, so we can use this image. All right, and no, what have I done? No. No, another one. No. Oh, this is, okay. So where is the actual height of? How come? Oh, I think there's an error in this file. Yeah, there was an error in this file. Huh, interesting. Okay. Okay. So I think we're going to use this as it is. And I am going to show this. Where do I want to start with? Where do I want to start with? Do I want to start with this? I want to start with this. And then I just want to show how this works, how we have it here. And I probably want to play a little bit with some of the values. And then I want to say that we're not going to do this live, because we're not going to do this. We're just going to point to the other file that has already been done. And we're going to point to the other file that's already been done. and that folks are welcome to follow that. Okay. Hi, and this is Jose Luis, and welcome to another hands-on exercise on this series, Introduction to Parametric Modeling. In this video, what we're going to do is we're going to try to model this structure called the Umbracle by Santiago Calatrava in Valencia, in Spain. It's like a canopy that is on top of a large promenade that is a walking path in the city of the sciences and the arts in Valencia. And it looks something like this grasshopper-wise. So what we have here is the canopy, and of course we can control a lot of parameters. This is actually a fairly detailed model with, we can control a lot of parameters, such as, for example, the how many spans, so the width between the spans, the height of the main arch, the width of the main arch, and then we can also control like certain other parameters, such as where these arches start, where do they end, how many ribs they have, how many ribs each one of them have, and many other things that relate to the profile of the steel, which is also variable. It's kind of cool because it starts bigger and it ends smaller here in this section. So it's going to be a fairly interesting modeling exercise. It's going to be a little longer because it has a lot of stuff going on. But I think we are at the point on this series where we know how to tackle all the problems that you're going to see here. And the good or the bad news is that this exercise is a little longer, perhaps, than many on this series. And also, I've actually already done this exercise in a different video. So if you go to this video, sorry, I forgot to mention that this image, the attribute, is to Javier Yaya Tour. It's a Wikimedia image from Wikimedia Commons. So I've actually done this exercise before in a series that is called Algorithmic Modeling Challenges. And in this video, I explain the whole process of how to think about the problem, how to design the sketches, and how to tackle the problem step by step and fully implement it both in Grasshopper, which is what I would invite you to do right now. And if you feel more advanced or if you want to learn C#, then there is a second part of this video, which is how to implement the same thing, but in pure C# scripting within Grasshopper. So I'm not going to record the video again, but I would like to point you to this video if you want to learn more, if you want to try this exercise right now. So there should be a description to a link to this video in the description, or it should be popping up as a card somewhere here. It's an interesting exercise. It's a little longer, but it will definitely help you polish a lot of the things that we have learned so far on this playlist. So I recommend you check it out if you have some time, or if you already feel very comfortable with what we're doing, then maybe perhaps move on to the next videos in this series and start learning more stuff and more techniques. Okay? All right, then either see you on this video, or I'll see you on the next video, or whatever life may find us in this digital world. Thank you very much, and see you on the next video. I wonder if I should... I wonder if I should... what should I do? Did I like this? Yeah, I think that was fine. Why not? Hey, and welcome. I wonder if... Oh, I can't believe I was using the exact same image on that video. That's kind of cool. Okay. All right, so that was it. Let me write down in my notes that E, E, E. Let me write that in my notes that we're doing the pointing to the A and C. Okay, so we've done that. We've done this, so this doesn't need anything else really. I'm going to save this. I'm going to clear this up. And then what else are we doing on the video today? I need to jump off at noon sharp. So I need to record the video. Yeah, and I don't want to start doing lists today, or at least right now, because I need to think that process. I need to really think that process through. So I wonder if we should just make like a brick wall or something. What's on my list of things to do? Stream. Yeah, I should be more prepared for these live streams, right? Okay. What should we do? I don't know, what should we do? Well, I'm actually going to record the other video in the meantime. So the other video that I wanted to do. And Anya, how are you doing? Good to see you. Let me record the other video in the meantime. And this is a video that I'm going to record that I want to put at the end of my other channel, my personal channel, the playlist that I have of GSD videos, and just inviting people to come here to this channel and check it out. Hi, this is Jose Luis, and if you're watching this video, it might be because you have finished the blah, 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 blah. Hi, this is Jose Luis, and welcome to what? Blah, 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 blah. Starting over again. Hi, this is Jose Luis, and if you're watching this video, it might be because you have reached the end of the playlist with the lectures for the course that I teach, Introduction to Computational Design. Starting over again. I can't believe this is going to take so much time. Hi, this is Jose Luis, and if you're watching this video, it might be because you have reached the end of the playlist where I was posting the lectures of the course Introduction to Computational Design that I teach at the Harvard Graduate School of Design. So you might be wondering now, if you've gone through all the videos and the lectures and you've done the exercises, you might be wondering like, what's next? How can I learn more? Or how can I keep improving my computational design skills? So in that case, what I would like to do is to invite you to check out one of the projects that I run, which is called Parametric Camp. Parametric Camp is a different YouTube channel where we do live streams on computational design. And I basically go live in YouTube and I record tutorials and we do all kinds of things. Like we do basic vanilla Grasshopper, we do C# within Grasshopper, we do C# and Python and Node and JavaScript in other environments. But all of the tutorials and all the contents that I create are typically related to some kind of computational design, generating graphics, generating form, and doing it in a creative way. So if you're interested in learning more, We have a bunch of playlists. We have a full playlist called Learning C Sharp from Scratch for designers. We have another playlist called Introduction to Parametric Modeling, which is basically learning Grasshopper also from scratch. We have other smaller playlists, like we have geometry jams, we have algorithmic modeling challenges. We have a lot of different things that we do in that channel. So if you're interested in learning more, I think there should be a pop-up card coming up at some point here, up and there. Otherwise, there will be a link to the channel here in the description. And we also have social media that you can use to follow us and to figure out when we go live. And we have a Discord server as well that you can join to be up to date with when we go live and with offline conversations. We can post questions, etc., etc. The link to that will also be on the description. So if you are interested in learning more, you may want to check this out, or you may want to check out other projects and other channels, similar channels that live on the internet with people doing similar work to the one that I'm trying to do. Okay, so thank you very much for considering this, and hopefully see you on the other channel and on the other videos, and maybe we actually get to meet in digital person while I'm doing my live streams and people join me in the chat and blah 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 blah. I think I'm rambling at this point. I'm going to start over again. Good morning, Chandra. Good to see you. I'm going to start over again. Hi, my name is Jose Luis, and people know that my name is Jose Luis. They've watched all the lectures. Hi, this is Jose Luis here. Oh my God, this is going to be bad. Hi, it's Jose Luis here, and if you're watching this video, it's probably because you are done with blah blah blah. Starting over again. Hi, it's Jose Luis here, and if you're watching this video, it's probably because you are at the end of the playlist where I posted the lectures for the course that I teach at the Graduate School of Design at Harvard called Introduction to Computational Design. And I'm going to start over again. Bula bula, exactly. Bula bula bula. Blah, 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 blah. I'm sorry for you folks who have to sit down and witness this stuff. It's terrible. All right. Let's try. Let's try again. Hi, this is Jose Luis here, and if you're watching this video, it's probably because you are at the end of the playlist where I posted the lectures for the course that I teach at the graduate school at Harvard called Introduction to Computational Design. If that's the case and you're wondering yourself, wow, that was cool, how can I learn more, or how can I keep improving my computational design skills? Then what I would like to do right now is to invite you to this other side project that I have called Parametric Camp. Parametric Camp is a YouTube channel where most of what we do is we do live streams where I go live on YouTube and with a chat window and with like-minded people from the community and friends who are live there, and we get to chat and we get to talk to each other while I'm recording live. And I typically do tutorials. Oh my God. Starting over again. Hi, This is Jose Luis here, and if you're watching this video, it's probably because you are at the end of the playlist where I posted the lectures for my course, Introduction to Computational Design, that I teach at the Harvard Graduate School of Design. If that's the case, and you're wondering now, how can I learn more? How can I keep improving my computational design techniques? Then what I may want to do right now is to invite you to check out this other project that I run called Parametric Camp. Parametric Camp is a YouTube channel where most of what we do is we do live streams where I go live and then I record tutorials live that we then edit and we publish as in a bit more of a polished way. But I do it live so that I can also enjoy the company of like-minded people from the community like you or other friends that have been following the project for many months already. And then we cover a lot of topics. We cover geometry generation algorithms, you cover graphics generations, and we do a lot of series where we explore certain topics a bit more in depth. So for example, there's a playlist called Introduction to Parametric Modeling, which is mostly about learning how to do all these things with vanilla Grasshopper. There's another playlist called Introduction to Computer Programming for Designers, which is learning C# from complete scratch. There's a few other mini series like algorithmic modeling challenges, geometry gems, stuff with WebSockets, C#, Python, JavaScript, Node. We touch upon a lot of different topics, and but most of them related to using computer code and using technology as a creative medium, which is the kind of things that I like doing and that I like sharing with the community. So if you are interested in learning more, in honing your skills, in maybe having a little bit of live fun during the live streams, make sure perhaps to go to the channel. There should be some link popping up on a card somewhere there, and the link will also definitely be on the description. Make sure to go to the channel, maybe consider subscribing and then turning on notifications so that you know when we are going to go live. And you can also follow us on social media. We use mostly Instagram and Twitter to talk to the world when we go live and when important things are happening. And hopefully see you there, see you on some of these videos, see you on our Discord server channel where we have offline conversations throughout the week, or maybe even see you live on the chat while we're doing some live streams. In any case, thank you for checking this playlist. Thank you for following the work that I do at my university and the work that I do as my side projects, and hope to see you soon somewhere here, there, on my channel, on this channel, anywhere. Thank you very much and see you on the next videos. All right, we're going to keep that one. now? Yes, how about now? We got it, right? Let me change the batteries of the other one so that this doesn't happen again. Hold on. Can you hear me now? Yes. Alrighty. So I was saying, the next thing that we're going to do on the playlist is we're going to talk about lists. So I'm going to do like we did for data trees. I'm going to break down some definitions of operations that we could do at the list level with Grasshopper. And then I would like to do a few examples, a few practice exercises to illustrate those. But I don't think I'm ready for that because I haven't written down really a breakdown of what I want to do. So, so I'm not ready for that yet. So I wonder, are you people who are watching this live, do you have any suggestions of a small Grasshopper exercise that we could do in vanilla Grasshopper that, because I don't want to do the brick wall, I don't think. The small exercise that we could do to practice what we've seen so far, like a small modeling. Imagine like a very small algorithmic modeling challenge. Think about it that way. Any ideas? I'm open to suggestions if you want to write them on the chat. Mm. Candela's umbrella structure. That's a little um, that's a little intense, perhaps. Lofting along a closed curve. Lofting along a closed curve. Now, you know what I'm thinking, actually? What I'm actually thinking is that it could be very nice to actually do the, because I know which exercises I'm going to be doing for lists. So maybe we could start with that. And then whenever, yeah, we can probably start with that. So let me go grab my laptop because I need to do some drawings here. I'll be right back. Hold on. Hello, we still there? Hold on. I am changing a couple of things. I don't know if I told you, but I changed offices. Have I ever told you about that? So I changed. I told you that I moved apartments. Did I tell you that I moved apartments very recently? So I'm in a brand new apartment. I'm in my house right now. But I'm in a larger apartment with more rooms, etc. And I just moved my office setup to a new room that has more space, more lights, but I just basically changed everything very drastically. So I'm still setting my thing. I'm still setting things up. So I need to move this coffee out of the way. I need to move. I need to move things around here. And then I need to project my computer into the network. How's everyone doing in the meantime? So yes, so I've made a decision. We're going to do some exercises on lists, even though we haven't really explained lists yet, but we're going to do a few exercises there. So I'm going to, and then I will probably do the lecture on lists. I will probably do it this afternoon. Well, actually, honestly, why not do it now? Yeah, I really need to plan these things ahead a little better. Hold on, I'll be right back. Because I have a lot of stuff going on. I need to plan these things a little better. So, okay. So, do I have my sketchbook here? And can you see my computer? Yes, you can see my computer there. Okie dokie. And then perhaps what we're going to do is we're going to do an exercise where what do we have? Okay. Okay, so we're going to do this, and I'm going to copy this. Where are we? Here? Yes. I'm going to paste this here, and I'm going to make this with, what is this going to be? It's going to be 7.1. 7.1 data lists. Okay, and then I'm going to drag this in here. Have that. I'm basically taking a file that I used in a workshop a while ago, and then I'm going to create a new one that is going to be I'm basically going to create a new one that is going to be this, and with some bifocals here, and a panel. Okay, and a panel that is connected there. And I'm going to be doing some vector point list, and we're going to crank this up a little bit. This is going to be very helpful. And so that's going to be one thing. The other thing that I want to take a look at is what is it that I would like to explain? So, all right, so we're going to take a look at, my favorite brush. Yes. Lists. Woo! Exclamation mark. All right, there you go. And then we're going to take a closer look at, for example, wait, can I save this? I'm going to save this and I'm going to open a different one here. Federico, how are you doing? Have you been here before? I'm not sure if we're familiar with each other. Good to meet you. We have a Discord channel. You're welcome to go there and introduce yourself. Okay. So we're going to now, I'm going to do, this is going to be, and then the things that we would like to take a look for is going to be, we're going to be looking at the length of a list. We're going to be reversing a list. Wait, should I do? Yeah, I'm going to do that in new layers. Oh. So the first thing that we're going to look is at the length of a list. Then we're going to take a look at reversing a list. Then we're going to take a look at retrieving items. We're going to take a look at list item. We're going to take a look at shifting. Oops, that one has to go on a new. We're going to take a look at shifting. We're going to take another look at, we're going to take a look at splitting. And then what else are we going to do? And we're going to take a look at sublisting. That should be a new sublisting. Okie dokie. So this is what we're going to learn today. Now, how are we going to do it? With Grasshopper Components. In Grasshopper. Okay. And then I have to remember to flatten and to graft. I would like to what do I want to do? I would like to start one by one adding these lists, doing the point list situation. And then for each one of them, flattening and grafting it and showing what the result is going to be. Okay, so I think we can do that here. And okay. I know, maybe I'm going to start from here. Oh no! Okay, so wait, so I need to do some magic and then paste it here. Okay, and then list item, reversing, and then here I need to take a look at splitting, and I need to cut it out, and I need to paste it. Okay. Okay. So how are we going to start? We're going to start here. And then when we switch here, okay, let's do this. So we're going to do, we're going to take 45 minutes and we're going to talk about lists. And this is a super, super important topic. So you better pay attention. Okay, let's do this. Hi, this is Jose Luis, and welcome to another video on the series. It's going to be a new section. That's what we're doing here. Another section. Okay. Hi, this is Jose Luis, and welcome to a new section on the series Introduction to Parametric Modeling, where in this section we're going to take a closer look at data lists and list-related manipulation. Why is that? Well, in the previous videos, we took a look at data trees, and we saw how in the case of Grasshopper, the way data is typically organized, like for example, when we subdivide a surface into UV points, is that the component gives us this structure that is called a data tree, where the data is divided into three main branches, each one of them with a path, and then each branch contains a list of data, a list of items, which is in this case 4 items, so 4 points for each one of those subdivisions. And then we also saw in the previous videos that there were two main operations that we could do at the level of data trees. That was grafting the tree so that now every single item had one element, had one branch for itself. So creating more complexity or branching out more the data. Or we could do the opposite operation. From the data tree, what we could do is like we could remove all the complexity and just trim it down, flatten it to the simplest possible data tree, which is just one tree with a branch called 0 and all the information, all the data inside of it as a one single list. Okay? Now, this is great, but very often when we work with geometry where we need to make sure that certain elements are connected to certain other elements, for example, it will be very often the case that data tree manipulation will either not be enough, or there will be operations that will be so drastic, they change so much of the structure of the data that it doesn't let us work with finer detail of how to match or how to combine different elements. So in those cases, what we will need to do is, instead of working or reorganizing the data at the tree level, very often what we will need to do is we will need to work with the data, but only at the list level. So instead of moving or changing the whole data tree, we will need to work with data and perform operations and sorting, reorientation only with data at the level of the list. And we will leave the whole data tree as the structure of the data tree as it was. So in this video, I would like to break down some concepts related to data lists. I would like to showcase some operations that we can do with lists of data. And I would like to show you examples of how to do that in the particular case of Grasshopper. Because we're going to be talking about lists. Lists are a data structure that is actually very common to most of the programming languages that I know of. So many of the operations that we will learn here, you will be very similar or will have mirrors in other programming environments. Data trees are a bit more Grasshopper specific, but lists are actually a very generic data structure. So the concepts that you're going to learn here will be transferable to other platforms. Okay, so what are we doing next? I'm going to start with list length. So let's get started. What is the first thing that I would like to talk about lists? Well, one of the most important properties, if not the most important property of lists, is what's typically referred to as the length. So let's take a look at that. What is the length? The length is the amount of items that a particular list contains. And knowing that will be super useful because we will very often need to do operations that somehow depend on how many elements are inside of a list. So in Grasshopper, how can we find the length of a particular list? So for example, here in this data tree, we know that we have 3 lists and we know that each one of them has 4 items. So there should be some component that tells us for each one of these that there are 4 items on that list. Where can I find that? If you remember, when we were doing data tree manipulations, we went to the Sets tab, and there was a full category called trees with all the components that made operations at the level of the data tree. So very similarly, there will be this other category called lists that will have a lot of components that will perform operations only at the level of the list. And actually, we will today focus mostly on many of these ones here, and we will leave these other ones perhaps for exercises or for hands-on examples. So if you look at the components here on the list, you can see that there's this one called list length, which tells us that it's measuring the length of a list. So if I do that, if I plug this in here and I drop it in here, we can see that this is the main data tree. And then if I plug in the data tree that is coming over from here, and I copy and paste this panel, you can see that what I get is that I am getting, in this case, I am getting the same data tree structure. I'm getting the same data tree here. But what I'm getting is for each one of the branches, I am getting the number 4. So 1, 2, and 3 branches, each one of them with the number 4, telling us that each one of the branches has 4 items. This will be super useful because then, for example, if I ever want to if I want to write a component that just takes the last element of a list, the last element is number 3. So I can do 4 minus 1 equals 3. So give me element number 3. We will see an example of that actually. Okay. All right, great. Now, I would actually love to also make you aware of the differences between the result that I get straight out of the component and the results that I would get if I graphed the data before. So remember, if I graph the data, what I'm getting is a new structure with one element per branch. So if I now try to find the length of the list for this data, what do you think I'm going to find? I'm going to give you 2 seconds. 3, 2, 1, boom. Indeed, what I get is the same in data tree, but now instead of a lot of 3 number 4s, what I'm getting is the number 1 for each one of the branches, because now the branches only contain lists with only one element. Does that make sense? Now, similarly, if I were to work with the flattened tree, what do you think would be the result that I would get when applying list length to this flattened tree? Another 3 seconds. 2, 1, boom, you got it. Instead of getting 3 number 4s, what I get now is the number 12, because I only have one list with all the points that are here on this surface right here. Okay? All right, does that make sense? Do you think that was reasonable? Hey, Chandra. So, yes, so some of my students will actually be holding a workshop at Digital Futures this summer, and it's going to be very similar in spirit to what we did last summer. It's going to be a continuation or an extension, perhaps a bit more hands-on. Last summer, it was a bit more theoretical. So you're welcome to check out their work. I will not be leading that one. It will be my students who will be leading it, but I'm sure it's going to be amazing, and I will be giving a guest lecture on that workshop this summer. Okay? Now, moving on. What is the next thing that we're going to talk about? We're going to talk about reversing a list. Now we're going to be retrieving an item. Yeah, because I think that's going to be useful. We're going to be retrieving an item. And I think that's going to be useful because yeah, that's going to be useful because now we can make a good connection with what we did here for length. So let me resort that. Quick transform. List item. I'm going to do that here, and then reversing. I'm going to. Okay. Okay. Wonderful. So what is the next thing that we're going to take a look at? Well, now that we know the length of a list, we can actually make certain assumptions, or we can use that information to perhaps do a super common operation on lists, which is also taking one particular item from the list, extracting one particular item from a list. That operation is typically called listing an item, or is typically called cherry picking an item, or is typically called extracting an item. There's actually not a standard naming for this. So what does that look like? I'm going to go back to plugging everything in here. All right, so this is our original list, and this is how the length that it has. And what I'm going to do now is I'm going to go to the lists operator, and I'm going to look at the list item component. The description says that it retrieves a specific item from a list, which I think is very interesting. So I'm going to drop that here. I'm going to copy, and I'm going to copy this here. And then what I'm going to do is I'm going to plug in here a panel. There you go. And then I'm going to plug here the list. So let me take a look at the inputs first. So input L is the list, the base list. I is going to be the item index that I want. So that's going to be, and it's going to be an integer. So for example, I'm just going to type here a number 10, and I'm going to move it to 0. And then we'll take a look at the W in a second. Okay? And then what I'm also going to do is, just for the sake of visualization, I'm going to plug out here, I'm going to plug the output. Okay? So what does that mean? What we can see is that now this was the original list. And what I'm doing is, from that original list, I am retrieving all the items that have an index number of 0. Which means that on this list, that would be, for this tree, because we have 3 lists, it would be this one first element, this first element of the second list, and the first element of the third list, which are the ones that we have here, and which you can see are the ones that were at the beginning of the surface. If I now crank this to the value of 1, you can see that now from the original list, we are retrieving the second item, the one with index number 1, the second item here, and the second item here. Those are the ones that you can see here. And it's very important to notice how these items on the new list, now they don't have the index number 1 anymore. They have the index number of 0, because if you remember, we discussed how index numbers always have to start at 0, and they have to be sequential. There can be no exceptions for that here in Grasshopper. So I can do 1, 2, 3, and 4, 5, 6. Well, this is very strange. We don't have elements 5 or 6 or 4 on the original list. Why am I picking those up? Well, there is another input here that is called wrap index to list bounds. What that means is that if this is true, and remember that hexagon means true or false as a data, if this is true, the selection will wrap over the full list, which means that if you choose an index that is over how many elements you have, it will go back to the beginning and it will start counting back from there. So if I actually set that to false, for example, with a Boolean toggle, if I set that to false, you can see that the component now gives me an error because there's no elements on item number 6 or item number 5 or 4. There's only 3, 2, 1, and 0. Does this make sense? All right. So as we typically do, now what would this operation look like if we do it on a grafted tree? Well, because all the elements on a grafted tree are elements that are now 0, then you're basically retrieving all the elements from the list. And if I do 1, I cannot take any one, etc., etc. What if I did it on the flattened tree? Well, because now what we have is one list with 12 elements. Now I only get the first one, and then I don't get this one or this one, but then as soon as I keep scrolling, then I now do have element 5 and 6 and 7 and 8 and 9, because the list that I'm plugging in here is much longer. The flattened tree has many more elements than when it was a data tree of lists. Okay. Now, this is very interesting, but we want to make sure, for example, how could I write an algorithm that makes sure, so for example, that always takes the last element of a list. So for example, let's say we are doing this surface and I want to make sure that I always pick up the last ones here. Well, I could do it 2 different ways. So first of all, because I know that, because for example, if I do it hard-coded and I have a number 3 here, the moment I increase the number of divisions, then my parametric rule breaks, because I have not accounted for that on the list item option. So I have 2 ways about this. In this particular exercise, because I know where the data is coming from and that I generated it here with this slider, I could plug this guy here right away. And if I do that, and I remove this, then I know that no matter how many elements I increase, I'm always going to be retrieving the last one because the divide surface and the list item components, they're both parametrically bound by the same parameter. So that could be one way to go. However, if we are coming from some very, very complex operations, blah, 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 if this was computation, whatever, we may have lost track of the number or the parameter that actually generated that sequence. Or if we don't really know there's no such parameter, we can't really do this operation. So a more programmatic way of doing this is saying, well, I know that here each list, I have 3 lists and each list has 4 elements. So, and I know that because I did list length. So what I can do is I can subtract from this value, I can subtract the value of 1, and then I can, so that I know the number of the last element parametrically, and then I can plug that in here. And then if I do that, then no matter how many elements I add, I'm always going to be fetching the last one. Does that make sense? This is a super, super common operation. Finding the list length and using that to retrieve the last element of a particular list. Super, super common operation. You're going to see that extremely, extremely often. Wonderful. What else can we do? Okay. What else are we doing now? We are reversing lists. The next operation that we're going to take a look at is a super, super common one that we will do very often, which is going to be reversing a list. And what does that mean? Well, that means as simple as taking a list of elements and whichever the order they were in, just flipping that order. So whatever was first goes last, and whatever was last goes first, etc., etc. It's a very simple operation. So, for example, let's go back to the main example here where we have a data tree with 3 branches and each one of them has 4 elements. If I want to, for some reason, reverse the order and make this the last one and make this the first one, and the same for each branch, what I can do is I can go to sets, list, and I can choose to reverse the order of a list. This component doesn't even really have options because it's just as simple as that. So I'm going to take this, I'm going to plug it in here, and then I'm going to plug the original list here, and I'm going to bring this down for comparison. And you're going to see that the point that was the first one here is now the last one on its own branch. The second one is the second to last in its own branch, and the same for each one of them. And I can see that visually if instead of displaying these numbers on the original tree, I display them on the flip tree. You can see that this point is now element 0, 1, 2, 3, and the same within each one of the branches. Okay, so super, super simple operation. And again, before we move on, I would like to take a look at what does reversing, for example, what if we reversed the lists that are in the grafted tree? Can you think about this for a second? Think about it. What would happen? Well, nothing really will happen because remember, if we have a list, if we have a tree with 12 branches, each one of them with 1 item, if you reverse a list that only has 1 item, then the list remains the same. There's no change. Okay, and we can see that here. Now, what if we reverse the list that has the tree that has been flattened? Remember, that was a list that now contains the 12 elements one after the other. If we reverse that tree, that list, then we will have all the elements, the 12 elements, but now reversed all of them from the beginning to the end. So if I plug the reverse list here, you can see that now this is the first one, and then it goes this way, and it goes this way here. Okay? Which kind of makes sense as well. So reversing lists will be very common. And also reversing list is also a technique that is sometimes used to fetch the last element of a list, like we did before. Because if you have a list and you want to take the last element, what you can do is you can reverse the list and take the first element, which is always going to be 0. So it's a bit easier to do. It's just that computationally it's not very efficient. It's not very efficient, but it's also sometimes done like in a quick and dirty way. But in this channel, we don't like quick and dirty. Okay, we like clean, nice stuff. We're pro computational designers. Okay, so try not to use that technique. Wonderful. What's next? What we're going to see next is the next operation, which is going to be shifting the elements inside of a list. What does that mean? At a very simple level, what it's going to mean is that instead of reversing the whole thing, if we have all the elements on a list and we may just want to reorder them to move them one position up or one position down or two positions up or two positions down, whatever, however much shifting we want to do. So that idea of like nudging or displacing the items in a list by 1, 2, 3, or n different positions, that is typically referred to as shifting. All right. So let me reorder. I'm going to bring this all the way down here. So let me plug this in here again. And let me plug this in here again to go back to where we were. And then let me show this here as well. Okay. All right. So I think we're ready to now. So we have the list. And what I would like to do is I would like to shift the elements on these lists that I have here. So you can see that I have the shift list component. And what I can do is if I look at the inputs, you can see that this is the list that I want to shift. The offset is how many elements am I shifting it up or down, and it has to be an integer. So let's take a look. This one is going to be a little more, so pay attention to this one. So I'm going to take the list, and I'm going to shift it by, for example, one element. So I'm going to shift it by one element. And then what I'm going to get here is going to be this new list, where if you take a closer look and you compare with the data tree, the original data tree, you can see that elements have moved one position up. So for example, the one that was the second is now the first one. The one that was the third is the second. The one that was the fourth is the third. And the one that was the first one, because there was no position before, has wrapped and is now all the way at the back of the list. Let's take a look at this visually, perhaps. So you can see that this was the arrangement of points at the beginning, but now if I shift them over one position, you can see that they all move like one unit up, and the one that was the last, it's now here at the beginning. And that works if I move 2 positions, if I move 3 positions, if I move 4 positions, they basically go and they remain the same because there were 4 elements on the list, but I can keep doing 5 and 6 and 7, etc., etc. I can actually do negative values. So if I change the slider to -10, I can also do, for example, I can offset them minus 1 unit. And then that will bring the first one to the last one, and all of them will be offset 1 unit. Okay. And similarly, how would this work if we did it on a grafted tree? Well, nothing would happen, because since we don't have a list of data, we only have one item, then we cannot really perform this operation. How would this work if we had it on the flattened tree? Well, we have all the elements, but now we can actually, oops, let me visualize this here. So we have all the elements, but now you can see that if I move them in one position, then the last one goes here, and then 2 positions, the 2 last ones move here, and all of them nudge 1 position. So we're basically affecting all the points at once, which also kind of makes sense. Let me go back to the original tree. Now, I want to highlight one of the options in the shift list component, which is the fact that this also has a wrapping parameter, which means that because this is by default true, this is what is making the elements, once the last element is gone, that's why it goes back to the beginning. But if this element was off, if this option was off, then we would have a very different behavior. So what's happening is that because all the elements are moving 1 position up, the first one has no position to go up. And because it has no position to go up, and we have set wrapping to be false, then it doesn't move to the end of the list as it used to before. Now it just gets disappear. It just falls out of the list. So shifting 2, shifting 3, if we have this set to false, then basically elements fall out of the list. And same for negative. So for example, if we want to do negative -1, what's happening is that all the elements are moving 1 position to the bottom, and the last one disappears. And then, because they all have to start from 0 as an index number, then that's why these 2 and these 3 remain with the same index number. The same for -2, -3. You see how we're dropping elements from the end of the list. So it turns out that shifting is a very common operation for moving things around, but also implicitly, because of this behavior, is also a super common operation to remove the first element of a list, to remove the last element of a list, or to remove the first 2, the last 2, etc., etc. It's kind of a byproduct, or like an implicit operation that we do, like a result that is not exactly shifting, but it's kind of embedded in the logic of shifting. So when actually I personally think that this behavior, the dropping elements, is one of the most useful ones in the shift list component. So I'm going to leave that there for you to sink it in, okay? Mm. The next operation we're going to take a look at is going to be called splitting. And a splitting, as the name pretty much says, is taking a list and then subdividing it in 2 lists based on some kind of index factor of where are we chopping that list. So it basically means chopping the list in 2 different lists at a particular position. So how does that look like? We're going to go to sets, list, and you can see that here there's a component called split list into separate parts. I'm going to drop this here. and you're going to see that I have the list and the splitting index. So I'm going to plug in here. Oops, I plugged it in the wrong way. I'm going to plug in here the list, and I'm going to say, for example, that I want to split at index number 1. So what that's going to give me is it's going to give me 2 lists on A and on B. And what this means is that here on the output A, what I get is everything that was before the index 1. And then for output B, what I'm getting is everything that was at index 1 and after. So for example, if I can look at that, what I get is at input A, if I'm splitting an index, I'm getting 0, 1, 2, etc. And then if what I'm looking at is B, what I'm looking is everything that was at index 1 and after. Okay? Now, as I said before, this means splitting, but if I don't want to use one of the outputs A or B, this is also implicitly a way of removing, for example, the first element of a list or removing the last 3 elements of a list. However you want to see it. It's also an implicit way of doing that. And as usual, if I do this on a grafted tree, what I get is parameter A, I get all the elements just as they were, and on parameter the output B, I get nothing because all the elements have an index of 0. And if I do this on the flattened tree, then I basically work with all the elements now from the full data tree because it was flattened. Okay, so we're already used to that logic. And what is the last operation that we're going to take a look at? That is going to be sublisting. Sublisting is very, very similar to splitting. It's just that instead of taking a full list and splitting it in 2 based on an index, what I can do is from a particular list, I can take a chunk, I can take a subsection of elements between a starting index and an end index. So in a way, it's like a better splitting because you have control over the beginning and the end of where you are cutting out that list. So what does that look like? So if I move all the way down here and I move my stuff over here, you can see that in lists, there is a component called sublist, which I can use to extract a subset from a list. And you can see that the inputs are going to be a list. D is going to be the domain of the indices to extract. So that's going to be a starting index and an end index. We've seen domains in previous videos. And then W is going to be whether if I want to wrap or not, similar to what I've seen in previous components. So I'm going to plug in the list in here, and then for the domain, I will need to create a new domain. I'm going to construct a new domain starting, for example, from, I don't know, let me start from the value of 1, and let me move this here. Let me start from the value of 1, and let me do the value of 2, for example. If I do that, I'm going to get a list that is going to look something like this. You can see that from the original list, and it's going to look something like this. So you can see from the original list, I have started with index number 1, including it. So I have taken the second element and I end in index number 2, including it as well. So I have these 2 elements. And therefore, what I have done is I have taken a chunk of that list that starts at index 1, at previous index 1, and ends at the previous index 2. So in a way, taking this out is a bit cleaner, it's a bit more of a programmatic way of doing this. So now, if I do that on the grafted tree, it's not going to work. But if I do this on the flattened tree, you can see that I can now reach out much farther, and because all the elements are part of the same list, as we typically do. Wonderful. So I think with this information, with understanding that lists have the most important property being the length of that list, and then that the basic operations that we can do are retrieving an element from the list, flipping the list upside down, reversing it, shifting it, so moving all the elements, offsetting all the elements 1, 2, 3 positions, and then splitting them and sublisting them, so extracting chunks of that list. Those are the most common operations that we can do with lists. And those are going to be the bread and butter of most of the operations that most of the modifications that we will do to lists, so that when we combine them together or we match elements with each other, we can do it in a very fine controlled way. Okay, so with that, I think I'm satisfied with, I think we have enough to start actually taking a look at how we can use this for our advantage. So I would like to invite you to join me in the next videos, where I think before we see anything, I think we're going to start doing a few hands-on exercises and practice all these techniques with examples. Okay, so let's do that in the next videos. But in the meantime, if you thought this was useful, maybe you want to like this video or even subscribe to the channel, and even this is crazy, but maybe turning on notifications so that you can be up to date when we go live and when we publish new videos. Thank you very much, and see you on the next videos. Bye. Okay, folks, I think I cannot do social today because I have a meeting that starts in 5 minutes. So I'm going to have to go. I'm sorry for that. How did this go? Was this UT Dallas? Oh, I've never been there. I have a lot of friends in UT Austin. Oh well, okay. Rose, I've seen you on the Discord before, haven't I? Rose Lotus Mystic. Anyway, thanks to you for being here. I also offer you blessings and gratitude. I have to go. I hope this was useful. And we're going live again this afternoon, and we are going to start at, when are we starting? We're going to start at 1:30 p.m. So Eastern time. So in 1 hour and 30 minutes. Okay. I think I need to change the stream because the stream is set for 1, and that is not correct. That should be 1:30. So if you want to know, if you want to see some exercises where we're going to practice list manipulation in Grasshopper, join me this afternoon for the new live streams. Okay. Thank you very much. I have to go. Bye bye. Thank you. Bye bye.